Hello students, welcome to Sri Jayendra's Rank Zone classes. I'm your friend and mentor for coming classes with respect to physics. This is lecture number 12 of a unit work, power and energy. So let's begin. Let's begin with today's class. In today's class we are going to discuss about the basically inelastic collision, and we are beginning with the head-on inelastic collision. So let's begin with today's class. First, it's an head-on inelastic collision. When I say head-on elastic collision, then I must understood that this was, let's suppose, a first object m1 moving with velocity u1. This was another object m2 moving with velocity u2. These two are moving in the same direction. They are going to collide somewhere, and after that they are moving with some different velocities. That velocities could be v2 and v1. This is the m1, this is the m2. Yes, and one more thing, this is inelastic collision. So when I say inelastic collision, it is for sure that momentum is conserved. In this, momentum is conserved, but kinetic energy, but the kinetic energy is not going to conserve. Kinetic energy is not going to conserve. I hope this is clear. Is it clear? So momentum is conserved, but kinetic energy is not going to conserve. So this is the case of the inelastic collision. So let's begin. That first object m1, velocity u1 moving in positive x direction, another object m2, velocity u2 moving in positive x direction. They are going to collide over here, and after collision their velocities would be v1 and v2. So let's just find it out what v1 and v2 will be. So we know the coefficient of restitution, which is relative velocity of separation divided by relative velocity of approach. So that should be v2 minus v1 divided by u1 minus u2. Let's put up the value and try to solve the questions. It's a v2 minus v1, that should be is equals to e into bracket u1 minus u2. So v2 is equals to v1 plus e into u1 minus u2. Here one more thing, this is inelastic collision. This is inelastic collision, and when I say it's an inelastic collision, value of e could be less than 1. Yes, it will be from 0 to 1. So do not make a mistake that let's put up the value of e is equals to 1 and try to solve it. It was the case of the elastic. This is an elastic collision. Please keep this in mind. Now we know that momentum is going to conserve. So from the law of conservation of linear momentum, I can have this. It's an m1 u1 plus m2 u2 should be equals to m1 v1 plus m2 v2. So we have a one relation that is of coefficient of restitution. We have another relation that is of conservation of linear momentum. From this two I am having a v1 that would be equals to m1 minus em2 upon m1 plus m2 into u1 plus 1 plus e into m2 divided by m1 plus m2 into u2. Same way for the v2, it's a 1 plus e into m1 divided by m1 plus m2 into u1 plus m2 minus em1 upon m1 plus m2 into u2. So this is the relation of v1 and v2. They are the velocities after collision respectively for the first body and second body. If we substitute e is equals to 1, whatever we are going to have, it is the same relation when we used to have with elastic head-on collision. So let's look at this carefully. If I put e is equals to 1, this would be an m1 minus m2 divided by m1 plus m2 into u1 plus 1 plus 1, it's a 2, 2 into m2, 2 into m2 divided by m1 plus m2 into u2. Yes, so these are the same. So this can be solved very easily. Again, the approach would be the same. If you don't remember the formula, go with the approach. How could I do this? So to do this, what I need to do is that first write down the relations of momentum conservation, and then write down the value of coefficient of restitution, and task will be done. Let's have a look. So the situation would be that this is the first object, this is the second object. This object is having mass of 2 kg. It is moving with 10 meter per second in this direction. This object is mass is 4 kg and it is moving with the speed of 5 meter per second in this direction. They are going to collide over here, and once they are going to collide over here, that this 4 kg is moving with certain velocity v1, this 2 kg is moving with certain velocity v2. One more thing, coefficient of restitution is given, and that is equals to E is equals to zero point 0.5. So the question is find out v1 and v2 for inelastic collision. Yes, because E is equals to zero point 0.5 is given. So what I need to do is that let's write down the conservation of momentum, which could be written as m1 u1 plus m2 u2 should be equals to m1 v1 plus m2 v2. So this m1 u1, it's a 2 into 10 plus 4 into 5. That should be is equals to 2 into let's this is v1 and this is v2. Yes, this is 2 into v1 plus 4 into v2. I hope this is clear. So this is 2 tens are 20, 4 fives are 20. It's a 20 plus 20, 40 is equals to 2 into v1 plus 4 into v2. This is relation number 1. Now what I need to do, it's I need to write down the E, which should be velocity of separation. It is the velocity of separation divided by velocity of approach. When I say it's a velocity of separation divided by velocity of approach, this E was half, zero point 0.5 is given. So velocity of separation, this is v1, this is v2, so this E would be equals to v2 minus of v1 divide by velocity of approach, it's a 10 minus 5. It's a velocity of approach, this is equals to 10 minus of 5. So this could be written as v2 minus v1 is equals to 10 minus 5, it's a 5, so it's a 5 by 2. This is relation number 2. And my first relation was 40 is equals to 2v1 plus 4v2. So let's just rewrite this by v1 plus 2v2, that should be is equals to 20 meter per second. This is 1 dash. I hope this is clear. So we have two relations, one is here, another one is here. Let's just solve it. It was the v1 plus 2v2 is equals to 20, and minus of v1 plus v2 should be equals to 5 by 2. So let's just add this. If we add this, this would gone 2v2 plus v2, it's a 3v2. This is equals to 20 plus 5 by 2, which should be 40 plus 5, it's a 45 by 2. This is equals to 3 into v2, and from this v2 is equals to this 3 5 15s. So this is 15 by 2, or we can say it's a 15 by 2, that means it is a 7.5 meter per second. I hope this is clear. So if I am having an v2, I can have the v1 as well. This is minus of v1 plus 7.5, this is equals to 5 by 2. So this v1 is equals to 7.5, that's a 15 by 2 minus of 5 by 2. It's a 15 minus 5, 10 by 2, it's a 5 meter per second. I hope this is clear. Was it clear? Are you sure? So v1 has been find it out, v2 has been find it out, and yes, you did it. Great. I hope this is clear. Is it clear? Is it? Is it? Okay, great. So shall I add something? Shall I? So if they want that, find out loss of kinetic energy in in above question. So what will you do? If they want to find out the loss of kinetic energy in above question, then what we understood is that let's check the data. The data says this was of 2 kg moving with 10 meter per second. This was of 4 kg moving with 5 meter per second. They are going to collide somewhere, and after that this was 2 kg, and it is the v1 was 5 meter per second. Yes, that we have find it out. And this was of 4 kg, and the 4 kg was moving with 7.5. It is a 15 by 2 meter per second. Yes, so it is the case. Now what they want the loss. So for loss, you need to write down the kinetic energy initial. When I say initial, I am talking about the system. So it's in 1 by 2 into m1 u1 square plus 1 by 2 into m2 u2 square. This is equals to 1 by 2 into 2 into u1 square, it's an 100, plus 1 by 2 into 4 into u2 square, it's a 25. So this would be equals to, this 2 has gone, this is equals to 100, plus this 2 2s are, it's a 25 2s are 50. So this is equals to 150 joule. This is the initial kinetic energy of the system. I am talking about the system. Let's just find it out, the final kinetic energy. That kinetic energy final would be given as, it's in half m1 v1 square plus half m2 v2 square. So that should be equals to 1 by 2 into m1, it's a 2, multiplied by the velocity phi, it's a 25, plus 1 by 2 multiplied by 4 multiplied by 15 by 2, it's a 15 by 2 multiplied by 15 by 2. Yes, so this 2 has gone, this is 25, plus 2 2s are 4, this is gone, 15 square, it's a 225, 225 divided by 2, which could be written as 25 2s are 50, this is 275 divided by 2. And when I say 275 by 2, when I say 275 by 2, this is equals to 137, 37 2s are 74, yes, it's a 137.5 joule. So look at this. Initially it was 150 joule. Finally it is 137.5. I want to find out the loss. So loss would be kinetic energy initial minus kinetic energy final. Initially it was 150. Finally it is 137.5, and the remaining amount is the loss. What it would be? What it would be? Yes, it's a 12.5 joule of loss would be there. I hope this is clear. But one more thing on which I need to focus is that this was the final kinetic energy, which is 137.5. This was the initial kinetic energy, which was 150 joule. So look at here, even kinetic energy is not going to conserve. When we were in elastic collision, this kinetic energy is conserved, and that's why look at this. When we have started, we have mentioned that momentum is conserved, but kinetic energy is not going to conserve. I hope this is clear. So this is the case of inelastic collision, in which we must be very careful that in this collision, in the case of the inelastic collision, we are not allowed to write conservation of kinetic energy, even not before and after collision. I hope this is clear. It is not going to conserve at the time of collision, that is for sure, but even in this case we are not allowed to write the conservation of kinetic energy before collision and after collision. I hope this is clear. Is it clear? Now any concern? No? Is it all clear? Great. Now let's find it out, that what would be the ratios of the velocity after inelastic collision. But to find out the ratio, I will take certain specific cases. That is, let's suppose a sphere of mass moving with velocity u. This is sphere of mass m moving with velocity u, hits inelastically with another stationary sphere of same mass, that it is going to hit with object having same mass, but it is at rest. So they are going to collide somewhere, and after the collision they are moving something like this. Let's suppose this is the first object, this is the second object, this is the second object, this is the first object, and this would be velocity 2, this would be velocity 1. Yes, and this is the time of inelastic collision. So I want to find out the ratios of their velocities after their collision. So what I can have is it's an E is equals to velocity of separation divided by velocity of approach. Now this separation could be written as v2 minus v1. Approach could be written as this is u1 minus u2, but as it is a 0, so I would write only u. So this is v2 minus v1 is equals to E into u. Yes, this is my first relation. This is my first relation. So, and one more relation I can have, it's the conservation of momentum, which says momentum before collision it equals to momentum after collision. So that could be written as m into u is equals to m into v1 plus m into v2. So this m has gone. So this could be written as v1 plus v2 is equals to u. This is relation 1. This is relation number 2, sorry. If I write it down this relation, if I write it down this relation, then from this solving first and second, I can have v1 is equals to u by 2 into bracket 1 minus e, and v2 is equals to u by 2 into bracket 1 plus e. So this would be their ratios. This is one of the favorite questions of the examiners. I don't know why, but this is this question people loves a lot. So please do remember these questions. Yes, and if you remember this formula, very good. If you can't, don't bother about it. You can just derive it in fractions of seconds. Yes, so don't bother to remember it. Yes, so this is their ratio v1 is to v2, that is equals to 1 minus e upon 1 plus e. Yes, same way loss in kinetic energy that we have already did it with a numerical practice. But if you go for the formula, then when I say loss, it would be a total initial kinetic energy minus total final kinetic energy. This is half m1 u1 square plus half m2 u2 square minus half m1 v1 square plus half m2 v2 square. Does it clear? Does it? Does it clear? Any doubts over here? Any doubts over here? Even we can solve this. Even we can solve this substituting the value of v1 and v2 from the above expression. This could be written as a very long formula would be there. It's a loss would be equals to half m1 m2 upon m1 plus m2 into 1 minus e square into u1 minus u2 whole square. So rather not to remember it and just go for the conceptual approach. Yes, or will you remember it? What will you do? Remember? Maybe certain students are there which are from medical aspirants. Yes, they say that, sir, we will remember everything. We know, we remember everything in zoo, we remember everything in bio. That means we are going to even remember these things. Great, you are great. So those who are engineering aspirants which are not, or maybe which are not capable enough to remember the things, go with the approach. This will help us. I hope this is clear. Is it clear? Is it? Are you sure? Great. So now ready for the questions? Are you? Are you ready for the questions? Let's have a look. So the question is that let's suppose this is an object having mass 5 kg, and this is having a velocity of, let's say, 20 meter per second. It is going to hit this object which is of having same mass, it's a 5 kg, but it is initially at 0. They are going to collide elastically and they are moving like this. Yes, this was first object, this was second object, this was second, this is first. So when we are going to calculate, this is v2, this is v1, and they have mentioned that e is equals to 0.2. Coefficient of restitution is 0.2. So let's begin then. First, according to the conservation of momentum, what we can say, it is 5 into 20, 100 plus 5 into 0, that should be equals to 5 into v1 plus phi into V2. So this could be written as it's a V1 plus V2 is equals to 20. This is relation number 1. I hope this is clear. Now second relation, E with the coefficient of restitution. It's a E that should be equals to V2 minus V1 divided by U, which is of 20. Now E would be equals to zero point 0.2, which is 2 by 10. This is equals to V2 minus V1. This is 20, so that's a 10 twos are. And from this we can have the relation, it's a V2 minus V1 is equals to 4. This is relation number 2. So we have two relations. One is the V1 plus V2 is equals to 20, and second it's a minus of V1 plus V2 that would be equals to 4. Let's just solve this. This has gone, and this is 2V2 that should be equals to 24. So from this it's a V2 which could be written as 12 meter per second. I hope this is clear. And if V2 is equals to 12 meter per second, sorry, it's a V1 which is 8 meter per second. Now you can find it out everything. You can find it out everything what you want. Yes, you can have a loss in kinetic energy, you can have change in kinetic energy, you can find it out that what fractions of energy has been transferred, you can find it out what fractions of kinetic energy has been retained, and each and everything. Yes, I don't think that any formula is required if you know this two basics. First, conservation of momentum. Second, value of an E to write it correctly. Is it clear? Is it? So if we understood this in very good manner, we don't require any formula at all. I hope this is clear. So does it clear up till now? Does it? Okay, great. So now let's have one more approach of inelastic collision. How that could be understood? That let's suppose this is the colliding surface, and one object is there. Let's suppose a one ball is there. It is going to hit this surface over like this, and from this now it is going to rebounding and moving in this direction. Let's understood at a first that this angle is alpha, this angle is beta, and as it is an inelastic collision, that is for sure that this one is v1, this is v2. So this velocities would be changed. So let's make a component of this two, v1 and v2. This is v1 cos alpha, this is v1 sin alpha, this is v2 cos beta, this is v2 sin beta. So observe the collision very carefully, observe the collision very carefully, then you must understood that this components, this v1 sin alpha and v2 sin alpha, that are the parallel components, that are the parallel components for the colliding surfaces. So they will remain the same. It's a v1 sin alpha that should be equals to v2 sin beta. Always remember all the parallel components, all the parallel components to the colliding bodies or the colliding surfaces, you can say so. For the colliding surface, all the parallel components will remain the same, they were not going to change. And all the perpendicular components, that this v1 cos alpha or v2 cos alpha, they need to be written with the help of E, that means coefficient of restitution. Now how should I write it? Let's have a look. How should I write it? This is E, that is the velocity of separation. This is velocity of separation divide by velocity of approach. So this could be written as separation. The separation could be written as E is equals to V2 cos beta divide by V1 cos alpha. Look at this. This V2 cos beta, this component. Look at this. That this is the colliding surface. And from this V2 cos beta is moving in this direction. So it is going to be separated from this colliding body. And this component, it's a v1 cos alpha, this component is going towards the going towards the colliding body. So that is the velocity of approach. So this is equals to v2 cos beta, and this is equals to v1 cos alpha. So we can write this as a v1 cos alpha into e should be or could be equals to v2 cos beta. So let's write it down this as a relation number 1. Let's write it down this as a relation number 2, and let's just do something with them. It's a v1 sine alpha should be equals to v2 sine beta, first relation, and this is e into v1 cos alpha, this is equals to v2 cos beta. This is relation number 2. Let's just take a ratio of this. So if I take a ratio of this, this is something like this. It's a v1 has been gone. Sin alpha by cos alpha, that would be 10 alpha by e, should be equals to this v2 has gone, and sin beta by cos beta, it's a 10 beta. So this is equals to 10 beta is equals to 10 alpha by e. I hope this is clear. Is it clear? Is it? Are you sure? Are you? Great. So this is the relation that can be remembered. One more thing, you can even have a calculation. You can also calculate the v1 and v2. How? Let's look at this. What you can understood is let's that this was our first relation, that is the v1 sine alpha is equals to v2 sine beta. This was my first relation, and e into v1 cos alpha, this is equals to v2 cos beta. This was second relation. So if I add it and square it, that could be written as v2 square sine square beta plus v2 square cos square beta. That could be written as v1 square sine square alpha plus e square v1 square cos square alpha. So if v2 is taken as a common, it's a v2 square is taken as a common, the remaining stuff would be sin square beta plus cos square beta, which should be equals to 1. That is equals to v1 square sine square alpha plus e square v1 square cos square alpha. So this v2 could be written as in a square root of v1 square sine square alpha plus e square v1 square cos square alpha. I hope this is clear. So this is the formula. This is the formula using which you can do this. What the concept is telling me? The concept telling me that all those components, please remember this very carefully, all those components which are parallel to the colliding surface would would be the same. Only those components which are parallel which are perpendicular to the colliding surface, only those components which are perpendicular to the colliding surface, they are going to be changed. This is what we require, and it has a very good and very logical applications with wit. I hope this is clear. So all the parallel components to the colliding bodies will remain the same. All the perpendicular components, you need to write it with the help of velocity coefficient of restitution. Does it clear? Does it? Are you sure? Are you sure? Great. So let's begin then with questions. Suppose the situation is something like this, that one of the object is there. This velocity has been given at 10 meter per second. This velocity has been given at 8 meter per second. It is moving in this fashion, moving in this, and it is going to move on this. Yes. So let's suppose this is v1, this is v2. E of this body, coefficient of restitution of this body, is given as 1 by 2, which is 0.5. The question says find out v1 and v2 for given given situation. Find out v1 and v2 for given situation. This is the requirement. So what I understood is that when they mention e is equals to 1 by 2 and e is equals to zero point 0.5, from that point of view I understood that this is the case of an inelastic collision. No need to say this, that this is inelastic collision, that we must understand. First thing. Second thing, so that means all the parallel components to the colliding bodies, this is colliding surface. Yes, the parallel components will be the 10 and here it would be a v1 would be the same. So you need to do nothing with them. It's a v1 that would be equals to 10. That's it. And all the perpendicular component, look at this. This 8 and this v2 are the perpendicular component to the colliding surface. Please, I request you one thing, that don't remember it that all the y components are the perpendicular. No, it is not the case. You must understand what parallel and what perpendicular is. So here 8 meter per second and v2 is the perpendicular component. So write them with velocity of separation divided by approach. Separation is the v2, approach is the 8. So e is equals to v2 by 8. From this I can have v2 is equals to e into 8. E would be having a value of 1 by 2 multiplied by 8. This would be 4 meter per second. So I am having v1 which is equals to 10. I am having a v2. That's it. You did it. Great job. v1 it's a 10 meter per second. v2 it's a 4 meter per second. Got it. This is the answer. I hope this is clear. Is it clear? Is it any doubts up till now? No? Ready for one more question? Let's have a look. Suppose this is the colliding surface and one of the object, that means let's say one of the ball is coming over here with speed v and it is moving in this direction, that this components has been given this as a v1 which is 10, this is v2 which is 4. They were asking to find it out this as v1 dash and this as a v2 dash, and coefficient of restitution of this surface it's a 3 by 10.3. Yes, so the question seems that find v1 dash and v2 dash. This is requirement. You need to find out v1 dash and v2 dash. Now tell me what you are supposed to do. What we understood is all the parallel components will remain the same. Now parallel components are in the y-axis. Yes, so what I understood is v2 dash is equals to v1 which should be v2, sorry, which should be is equals to 4 meter per second. So one of the tasks I did it. Now let's work for the second, that this are the perpendicular component to the colliding surface. So from the colliding surface they are perpendicular, and if they are perpendicular they need to be right with coefficient of restitution. So e could be written as velocity of separation. Look at this, this is moving out, this is moving away from the surface, so it is a velocity of separation. It's a v1 dash divided by this is the object that is moving towards it, so this is v1. So while I say this, I must say v1 dash is equals to e into v1. E, that is equals to 3 by 10 multiplied by v1, that is equals to 10. This has gone and this is 3 meter per second. So I am having v1 dash, I am having a v2 dash. That's it. You did it. Is it clear? Is it clear? Great. Let's have certain MCQs and then again we will move to the very good applications. Let's begin first. What does it say? It says in an elastic collision the kinetic energy after the collision, yes, is same as before collision. No, is always less than before collision, is always greater than that before collision, maybe less or greater than that before the collision. In an inelastic collision we only understood that there is a loss of kinetic energy, and when there is a loss of kinetic energy, it is always less than that before collision. So this three are the incorrect and this one would be the correct. Got it? Are you sure? Are you? Great. Next, it says that one sphere collides with another sphere of same mass. Their masses are same at rest inelastically. If the value of the coefficient of restitution is 1 by 2, the ratio of their speeds after the collision shall be great. So let's calculate it. It's one sphere having mass m and another sphere having a mass m. One sphere collides with another sphere of same mass. Let's suppose this is velocity u, this is 0, and they are going to collide with each other. So what I can write, it's let's suppose this is first object, this is second object, this is second, this is first, this is moving with v1, this is moving with v2. The ratio of their speeds are required. So let's do it. First, it was the momentum conservation that could be written as m into u. M into u would be equals to m into v1 plus m into v2. So this m has gone, this m has gone, and I'm having left with the u is equals to v1 plus v2. This is my first relation. And second relation, it's a coefficient of restitution. This is E is equals to velocity of separation, that's a v2 minus v1, divide by velocity of approach, it's a u. Coefficient of restitution, a 1 by 2. So this is equals to 1 by 2 is equals to v2 minus v1. So this is equals to u by 2. This is my second relation. So I'm having two relations. Let's just solve it and try to get the answer. So the first relation says it's a v1 plus v2, that is equals to v1 plus v2 is equals to u, and the second relation says it's a minus of v1 plus v2 is equals to u by 2. So if I solve this, this has been cancelled. So v2 plus v2, this is equals to 2v2, this is equals to 3u by 2. So v2 should be equals to 3 by 4 of u. v2 is equals to 3 by 4 of u, and v1 could be calculated as that v1 plus 3 by 4 of u should be equals to u. So this v1 is equals to u minus 3 by 4, it's a 1 by 4 of u. So while I take a ratio of this, it's a v1 is to v2, that should be is equals to 1 by 4 of u multiplied by v2, this is equals to 3u by 4. So this u has cancelled, this 4 has cancelled, and this is equals to 1 is to 3. So this would be the answer, 1 is to 3. Now one very good thing is that this ratio is, look at this is very surprising, this ratio is independent of mass of the body, as well as it is independent. I'm talking about the ratio, I'm not talking about the v1 or v2 individually. I'm not talking about the individual v1 or v2. I once again say it, I am talking about the ratios. So the ratio of this situation is independent of mass, even it is independent of their initial velocities. Yes, even with which it is striking doesn't bother. Yes, the ratio depends only this only. It's a 1 minus e upon 1 plus e. I hope this is clear. Is it clear? Great. So are you ready? Are you ready with certain very good applications? Are you? Let's have a look. Yes. So from the theory we are going to move to the applications. Let's work to find out, to determine the coefficient of restitution. So what we are supposed to do is to determine the coefficient of restitution between two materials. One of them is taken in the form of a very heavy plate and the other in the form of a small sphere. And let's suppose the small sphere is dropped on the plate from a height h. Here it has been dropped, so this is from this point of view, it's a u equals to 0, and it hits the plate with velocity v1. I mean, say it's a u1. So after striking it, let the sphere rebounds to a height h1. Yes, this is the height h1 after collision with the plate. So this could be written as E. This was the situation that object was there. It has been dropped from here. It's a u equals to 0. This height was the h, and after it has been struck to it, it has been, let's suppose, rebounded to the height h1. So this was the situation. Then I can write it's a E. Coefficient of restitution could be written as v2 minus v1 divided by u1 minus u2. Yes. So initially it has been 0, so this is E is equals to minus of v1 divided by u1. This was the u1. So according to the motion in a straight line, we have this relation. If you remember this, it's a v square minus u square equals to 2gh. Initially it was 0, so final velocity that I have mentioned as a u1, that is equals to root 2gh. So here it's a root 2gh, and when the ball rebounds, it is moving in this direction. So this is velocity of separation. Yes, it rebounds with a velocity v1 and it reaches to a height of h2. But here it's a final velocity would be a 0. So we can write like this. It's a v1, the velocity I have calculated over here. It's a v1 that would be equals to minus of root of 2gh1. I have mentioned negative sign because v1 is in opposite direction to u1. Is it clear up till now? Is it clear? So now I am having v1, I am having u1. So what I can have is it's a e that should be is equals to minus of v1 divided by u1. That would be equals to minus of minus, that would be the plus. This is root 2gh divided by root 2gh1. So if I write e, that is equals to root of 2gh1 divided by root of 2g. This could be cancelled, so only the term I have been left. It's a e is equals to root of h1 by h. If I square this, I can write it's an e square. It's an e square that could be equals to h1 divided by h. So from this, it's an h1 is equals to e square into h. Even this can be written as e to the power 2 plus 1, e to the power 2 into 1 into h. So in a generalized term, this could be written as hn is equals to e to the power 2 into n into h, where n is the height raised after the nth bounce. Yes, after nth collision. So this is the relation we are looking for. This is hn is equals to e to the power 2n into h. This is the height of an object after nth collision or after nth bounce. One more very important aspect. Look at this carefully. Look for the magnitude. So what does it say? It says that E is equals to V1 divided by U1. I'm talking about the magnitude. Yes. So this could be written as V1 is equals to E into U1. This could be written like this. So even this could be written like this, that Vn is equals to E to the power n into U. I can say it's an initial. So this is Vn is equals to e to the power n multiplied by u initial. So this is the velocity after n bounce, or we can say velocity after n collision. So these two are the very very important relations that we must keep this in mind. One of them is the hn is equals to e to the power 2n into h, and another is the Vn is equals to e to the power n multiplied by u initial. I hope this is clear. Yes, if I say it's an h naught, then this h naught is the initial height. H naught is the initial height. So please note it down. Please note it down. This two relations. Please note down this two relations. And we are going to have numericals based on these two relations. Have you noted it? Have you? Have you noted it? Great. So now ready for the questions? Are you? Are you ready for the question? Let's begin. So the question says that let's suppose this is ground. and object is there. It has been dropped from here. This is a height of 100 meter, and this surface is having certain losses, and that could be represented as E, coefficient of restitution, which would be, let's suppose, 0.5. So they ask that find out velocity of an object after third bounce, and and height of an object after second bounce. So this is requirement. Yes. So you what do you want? That you want a velocity of an object after third bounce. You want an velocity of an object after third bounce, and you require an height of an object after second bounce. So how will you do it? How will you do it? You have been given E is equals to 0.5. So what I am relations is, it's a Vn is equals to E to the power n into U initial, and Hn, this Hn is equals to E to the power 2n into initial height. So I am having an initial height, it is of 100 meter, but I am not having an initial velocity. So let's just calculate it over here, that when it reaches here, this should be root of 2 into g into h, and that h is given as 100. So let's just try to solve this. It's a vn, is equals to e to the power n multiplied by root of 2 into g into h. So this is equals to, when do you require? It's a velocity after third bounce. So this is e to the power 3 multiplied by root of 2 into 10 into 100. I hope this is clear. E is the value of 0.5, so it's a 1 by 2 multiplied by 1 by 2 multiplied by 1 by 2 multiplied by, this is 100 and this is 20. So this could be written as 100 into 20, so 100 into 4, so this is, yes, 100 into 2, 200 into 10, 2000. 2000 could be written as 2000 could be written as, this is 2000. So this could be 1 by 8 multiplied by 1 multiplied by 100. It's a 10 into 10 to the 20, 20, it's a 4 into 5, it's a 2 into root 5. Yes. So this is 20 into 400 into 5, 2000. Yes, right, written it correctly. So this is 10 to the 20 divided by 8, 20 by 8 multiplied by root of 5, could be written as, this is 2 4s and this is 2.5 into root of 5 meter per second. This is 2.5. I hope even this was your answer. Is it clear? Is it? Are you sure? Now let's calculate the Hn, which was e to the power 2n into h naught. When do you require it? You require it after second bounce. So this is equals to e to the power 2 into 2 multiplied by initial height, it was 100. So this is equals to e to the power 4 into 100. E to the power 4, it's a 1 by 2, 1 by 2, 1 by 2 and 1 by 2 multiplied by 100. So if I do this, this is 100 twos are 50, this has gone. 50 twos are 25, this has gone. So this is 25 by 4, which should be, it's a 4 6 are 24, it's a 6.25 meter. I hope this is clear. So this was height and this was the velocity after nth bounce of the object. Does it clear? Does it? Are you sure? Any doubts over this? Is there anything? Any doubts over this? Is there anything? Anything? No? Great. Let's look at the application. The application says the total distance traveled by the sphere before it stops bouncing. So the situation would be something like this, that let's suppose this is the colliding surface and this ball has been dropped from here. This is, let's say, height h. So once it is going to collide over here, and after first bounce, let's say after first bounce, it is at here. This is height h1. So from here to here, this is again the h1 because it is moving up, and from there its final velocity would be 0. So once its final velocity would be 0, now it is started moving down. So this is h1. From this, now again it is going to moving down. So from here it is again going to down, and once it is again going to down, it is again colliding from here. So now let's suppose it raises to height h2, again moving down a same height, it's an h2, again colliding over here, and it reaches to this height h3, and this is h3, and on so onwards. This has been continued till infinite. So I hope this is clear. So the total distance traveled by an object, that is equals to this. Initially it is h, then it is 2h1, then it is 2h2, then it is 2h3, and this will be continue. Yes, we have this relation that hn is equals to e to the power 2n into h, and when I say hn is equals to e to the power 2n into h, I can write it's a d is equals to h plus 2 into h1. It is e to the power 2 into 1. It's a first collision, so it's a 2 into 1 2. It's a second collision, so it's a 2 into 2 4, so it's a 2 into e to the power 4h. Next it's a 2 into 3, it's a 2 into e to the power 6h, and this must be continuing. So I can have this h over here, and let's suppose this is a series from which I can have 2 into e square into h as a constant. So if I take 2 into e square into h as a constant, I am having it's a 1 plus e square plus e to the power 4, and then tends to an infinite. Got it? Now, if you observe this series very carefully, do you find anything? Do you find anything that you understood about the series? Anything? Yes, it is the GP, geometric progression. Yes, if you take a ratio, you just take a ratio of the second term to the first term, it's a e square, this is 1. Take a ratio of this term, third to the second, it's a e to the power 4 divided by e square, again e square, again e square, e to the power 6 to the e to the power 4, again e square. So the ratios are same, ratios of their consecutive terms are same, and when the ratio of the consecutive terms same, it says it's a geometric progression. I hope this is clear. So what you need to do is you need to just add this GP. For that you must have relation for the GP. For the relation of the GP is equals to, for infinite GP actually, it is Sn is equals to a upon 1 minus r. I hope you must remember this. If you are not, don't worry, just look at this. The a would be the first term, a would be the first term of GP, and r is the ratio of second term to first term. So what I'm supposed to do is, this is the addition, and for me it's a distance, it's an h plus 2e square h upon first term. Look at this, my GP was something like this, it's a 1 plus e square plus e to the power 4 plus e to the power 6, and onwards to an infinite. So for me first term is the 1, so I have written it over here, upon 1 minus r, 1 minus r is the ratio, this e square by 1, it's an e square, e to the power 4 by e square, it's an e square, so it's a ratio. So this is equals to 1 minus e square. So let's just try to solve it. If I solve it, it's an h plus 1 plus 2e square upon 1 minus e square, and if I take an LCM, I can have this, it's an h into bracket 1 minus e square plus 2e square. So this minus e square plus 2e square, only the 1 plus e square will remain, and this is the distance, this is h into bracket 1 plus e square in upon 1 minus e square. This question has been asked in JEE mains, as well as in the NEET examinations when AIPMTs were taken. I hope this is clear. Is it clear? So can you do this kind of questions? Can you? Are you sure? Any doubts over it? Any doubts on this? Is there anything? No? So will you be able to solve this? Yes. So now let's suppose someone ask me that what would be the total time taken by the ball to stop bouncing. So it is the same case. It is the same case when we have decided that initially dropped from this edge and from this h1 again moving with h1 and h2 h2 and h3 and onwards. So what I need to do is I understood that when object has been dropped by a height h from 0, that means initial velocity is 0, then I can have the relation it is h equals to half gt square. And when I am having h equals to half gt square, it is t should be equals to root of 2h by g. So the time t is equals to initial time t plus 2t1 plus 2t2, that is the time required for after second bounce, time required after third bounce and onwards. So basically the things will be the same. This t could be written as root of 2h by g. This t1 could be written as 2 into 2h1 by g. This t2 could be written as 2 into root of 2h2 by g. This t3 2 into root of 2h3 by g. And this h can be replaced as hn is equals to e to the power 2n into h naught. So after first bounce it could be written as e square 2 into e square into h by g. Second bounce 2 into e to the power 4 into h by g. The third bounce it's a 2 into e to the power 6 into h by g and onwards. So when I do this what I can have is the root 2h by g as a constant, and in the bracket I am having this. It's a 1 plus 2 under root of e square plus 2 under root of e4 plus 2 under root of e to the power 6 and something like this. So if I solve this I am having t is equals to root of 2h by g into bracket this. Now this is gp again. Look at the ratios. This is again gp of infinite terms. So it's Sn is equals to a upon 1 minus r. So this is equals to, this could be written as, this is root of 2h by g into bracket 1 plus 2e into bracket this is a, which is equals to first term divided by 1 minus r, and the r could be written as e divided by 1, which is e. So this is 1 plus 2e into bracket 1 upon 1 minus e. This could be written as 1 plus 2e upon 1 minus e, and that could be written as root of 2h by g into bracket 1 minus e plus 2e divided by 1 minus e. This is the time of flight. It's a root of 2h by g into bracket 1 plus e upon 1 minus e. Got it? Got it? So this is the time. It's a root of 2h by g into bracket 1 plus e upon 1 minus e. Now they ask for the average speed of the ball during its entire journey. So how could I find out the average speed? Average speed could be calculated as total distance traveled divided by total time taken. The total distance traveled I have derived it. It's an h into bracket 1 plus e square upon 1 minus e square, and the total time taken, that is equals to root 2h by g upon 1 plus multiplied by 1 plus e into 1 minus e. So if I try to solve this, I am having this average speed, that is equals to root of gs by 2 into bracket 1 plus e square upon upon 1 plus e whole square. I hope this is clear. Is it clear? Is it? Are you sure? Are you sure? Any doubts over this? Anything? Anything? Are you sure? Yes. And if they ask average velocity of the ball during its entire journey, yes, so the average velocity is equals to net displacement divided by total time taken. The net displacement is h only because initially it has been dropped from here, and after so many rebound, let's suppose first, second, third, and such as infinite, after that it will end its journey over here. So if you understand vertical displacement, it is only the h. So the net displacement, it is only the h divide by total time taken, and this total time could be written as root of 2h by g into bracket 1 plus e upon 1 minus e, and this is average velocity. I hope this is clear. This is the average velocity, which could be written as root of gs by 2 into bracket 1 minus e upon 1 plus e. That's it. So these are very good questions. These are very good applications. They have been asked so many times at various examples, various examinations, direct as a formula. Yes, either to remember this or ready to derive it. But these are the very very important questions, and this has been asked in various times in various different applications at various levels. I hope this is clear. Is it clear? Is it? So now let we do same thing for some different approach. Let's have a look. Let's suppose you have been given that you have one of, this is y, this is x. You have a projectile, and it has been projected with you while making an angle theta. It is going to be launched at here. It, yes. So this was the range, or I should say initial range r naught. Now after one collision, it is again going to collide with this. Again this velocity and this theta will remain same. But let's suppose this is the r1. Again one more time, again the parameter remain the same, and r2. And this is, let's suppose this is rn. Yes, you need to find out. You need to find out the relation that, let's first find out relation between r1 and r0. So what can you do? What can you do? And how can we do this? Is there anything that you understand that I should go with this? Is there? Let's look at this very carefully. That the situation is something like this. Yes, this has been u, this has been theta. So this would be the u cos theta, and this would be the u sin theta. I hope this is clear. Yes. So this u cos theta is always parallel to the striking body, while u sin theta will be always perpendicular to the striking body. So the situation will be that if it is going to rebound again and something like this, then even u cos theta will be in the direction which is not going to change. But when it has been landed over here, this is, let's suppose I take it a name as in v. Yes. So this u sin theta and this v, these two are altogether different one. Yes, because they are colliding, and they are the perpendicular component. So what I should write, it's an r naught, that should be is equals to 2 into ux, that is the velocity in horizontal direction, multiplied by uy divided by g. Now what I need to write, r1, it's a 2 into this ux will remain the same, but what should I write for uy? So let's have a look. We have coefficient of restitution. Please look this very carefully. We have a coefficient of restitution. This is the velocity of separation divided by velocity of approach. It's a uy. So this v can be written as e into uy. I hope this is clear. So this is e into uy divided by g. So let's write it down. So it's an r1, that is equals to 2 into e into ux into uy divided by g. So if I look at this, unless e, this is the r naught, so this could be written as r1 is equals to e into r naught. This is the relation. And one very important thing is we can write like this, it's an Rn. It's an Rn that could be written as e to the power n into R naught. I hope this is clear. So this is the relation. This is the relation. If I have been asked, if I have been asked that find out range after fifth bounce. So what I am supposed to do is I need to write only this thing, R5 is equals to e to the power 5 into R naught. If data has been given, if data has been given, calculate the R naught, put up the value of the e and do it for themselves. I hope this is clear. Is it clear? Is it? Are you sure? Now, let's suppose they have asked that find out total horizontal distance traveled by an object. So you want to find out the total horizontal distance traveled by an object. How will you do it? It is as simple as that. It's an R naught plus R1 plus R2 plus R3 up to infinite. So this is R naught plus this is R1, which is E into R naught, because I understood that Rn is equals to e to the power n into R naught. When I say first, it's a e to the power 1 into R naught. So this is E R naught. This is E square R naught. This is E cube R naught and onwards. Yes. So from this R naught could be taken as a common. This could be 1 plus e square plus e cube, and this can extend up to an infinite. So if you observe this carefully, yes, this is the GP, geometric progression. What I need to do is it's an R naught into bracket, it's addition, it's a upon 1 minus R. A is the first term, this is 1 upon 1 minus R, e by 1, e square by e, it's a. So that's it, you did it. It's a nothing bigger than you understand it. Yes, that this is the summation of infinite. How should I do this? No, it is not like this. It is just a single term. So this total range, or I should say this is the total distance, total horizontal distance in fact, could be written as R is equals to R naught upon 1 multiplied by 1 upon 1 minus E. Yes, and if you observe this very carefully, if this is the case, if this is the case of elastic collision, I understand that this was the case of the inelastic collision, but if this is the case of the elastic collision, then then total horizontal distance can be written as this R is equals to R naught. This was the master formula, 1 upon 1 minus E. Now for elastic collision, E is equals to 1. So this is R, or total horizontal distance is equals to R naught upon 1 minus 1, which is an infinite. Why why it should be an infinite? Because there are no losses would be there, and if no losses are there, that means this ball will keep moving. This is what Newton's first law is all about, that if an object is there, it is moving with certain velocity, then it will keep moving if no unbalanced external force is acting on it. This is just the Newton's first law, and this is just the proof of it, that if E is not there, that means if losses are not there, if there is no loss of energies are there, then this object can keep moving and it doesn't have any problem. in keep moving up to infinite distance. Got it? Are you sure? Do you find this interesting? I love this. Is it clear? Great. So will you do one more thing? Will you? Great. Let's have a look. Yes, please keep this continue. That this is the first. Let's say this is the second. Now you know all the terminology, you all the parameter. This is u, this is theta. Now a time of flight of this is 1, time of flight of this is 2. Let's suppose this is t naught. I mention it as a t naught. This is time of flight of 2. H max, it's an h naught. This is h1. Yes. Then okay, go then. Yes, go with this. That find out relation between, let's call it this t1, this is t naught, this is h1, this is h naught, between t1 and t naught, and h1 and h naught. Yes. So let's begin then. Let's work started with the time of flight, which is 2u sine theta by g. So which is, this is 2 into uy divided by g. Now there is no need to explain you that this is t naught. When I write t1, I should write it's a 2 into e into uy divided by g. I hope this is clear. Is it clear? That e could be written as v1 divided by uy. Yes, so it's a v1 is equals to e into uy, and I have written it over here. I hope this is clear. Is it clear? Any confusion? Yes, great. So this t1, that could be written as e multiplied by 2 multiplied by u of y divided by g, and this e into 2 into uy by g, this is could be written as, this is t1, that would be equals to e into t naught. Same way for the h max. How should I write this? It's an h max is equals to uy square divided by 2g, and let's say this is h naught. So h1 could be written as, look at this, it is just the square. So what I need to do is, it's an e square into h naught. I hope this is clear. So for a generalized term, I can write like this. It's a tn is equals to e to the power n into t naught, and for the hn, it's a e to the power 2n into h naught. Yeah, I hope this is clear. Is it clear? Is it any confusion over it? Any confusion? Are you sure? So now you must know the generalized relation of range, generalized relation of time of flight, generalized relation of hn. It's a maximum height after nth bounds. Is it clear? Is it? So will you do one question? Will you? Let's have fun. That this is the object, and it has been thrown something like this. This is u equals to 30 meter per second. This is 30 degree. If e is equals to, let's suppose this is 0.2. If e is equals to 0.2, find out first range after second bounce, second time of flight after second bounce, and third, which is h max after, let's say, even it is at second bounce. So I know that Rn, it's a range after nth bounce, it would be the e to the power n into r naught. Time of flight is equals to again e to the power n into t naught, and h max, it would be a e to the power 2n into h naught. So what you need to require is, you require this original r naught, t naught, h naught. So let's just get it and solve this. The r naught would be equals to, R naught would be equals to, it's a u square sine 2 theta divided by g. This u square, this is 30 30, it's a 900 multiplied by sine 2 theta, it's a sine 60. Sine 60 could be root 3 by 2 divided by g. This has gone, 92s are 45, so range would be, initial range would be 45 root 3. Time of flight, this time of flight is equals to 2 into u into sine theta divided by g. This is equals to 2 into u, initial velocity, it's a 30 into sine 30, which is a half, divide by 10. This 10 3s are 3, this gone. So initial t naught is equals to 3 seconds, and I required h naught, which should be u square sine square theta divided by 2g. This u square would be equals to 30 into 30, it's a 900. Sine square theta, it's a 1 by 2, 1 by 2 divided by 2 into 10, it's a 20. So this has gone, this has gone, this is 33s are 90 divided by 8. So now what I want a range after second bounce. So R2 is equals to, E square into R naught. E square, the E would point to, it's a 2 by 10 into 2 by 10 multiplied by R naught. Initial range was 45 root 3. So this is 45 into 4, 180 divided by 100 into root 3. This has gone. So this is 1.8 multiplied by root 3 meter. This is range after second bounce. What next? The next is the time of flight after second bounce. So time of flight, Tn is equals to e to the power n into t naught. So t after second bounce, it's a e square into t naught. E square, again it's a 2 by 10, 2 by 10, and time of flight was the 3 seconds. It's a 2 2s are 4, 4 3s are 12, it's a 12 by 100. This is equals to 0.12 seconds. This is time of flight after second bounce. Is it clear? Is it? I hope this is clear. And one more thing, it's an h max, after second bounce. This is equals to e to the power 2n into h naught. So this is e to the power 4 into h naught. E to the power 4, it's a 2 by 10 into 2 by 10 into 2 by 10 into 2 by 10 multiplied by h naught. This maximum height, what was it? Yes, it was 90 by 8. So it's a 2 2s are 4, 4 2s are 8. This has gone, and I have been left with the 92s are 180. So it is like this, it's a 9 2s are 18 divided by 1000. So it's an 18 into 10 to the power minus of 3 meter. This is height after second bounce. So did you got this? Are you sure? Do you like it? Do you? Are you sure? Great. So this are the questions that are very interesting questions, and from this questions various applications has been derived. I hope this is clear. So I'm sure that you will be capable enough to do this kind of questions. So now let's move to the one more application of collision. Basically the situation will be that this is one of the pendulum over it. Yes, in reality this is ballistic pendulum, which is used to measure the velocity of a bullet. Yes, but let's understood it that this is mass m, and it has been thrown, it has been hit, it has been moving with velocity u. In a reality it's a bullet which is moving with velocity u. This is the pendulum, and this is the bob having mass m, and initially this is at rest. Initially it is at rest. Now as it is going to hit it, as this bullet is going to hit it, this bullet plus this pendulum, will be moving towards this. Yes, and here this height h, this is height h which it has been raised. Yes, so what what we required is find out maximum height h that can bullet and pendulum can raised. So one very surprising thing is that they have mentioned only the collision. They have mentioned that this bullet is going to collide with this. That's it. They have not mentioned whether it is elastic collision, whether it is inelastic collision, and what it would be. So when they have not mentioned, we have freedom of, we can only conserve the momentum. We can only conserve the momentum at a point of collision. We are not going to conserve here kinetic energy. No, we cannot say so that kinetic energy is going to conserve. Can you? No. Why? Because you don't know that which kind of collision it is. I hope this is clear. So now first what I need to do is let's apply a momentum of conservation in this boundary. Let's suppose at this. Yes, this is the site of collision at which collision occurs. So I'm going to apply a momentum conservation at this point. So it would be initial momentum of the system that would be equals to final momentum of the system. So initially only the m into u plus this was at rest, so it was m into z. This is equals to m plus m into v. Yes, initially the situation was it was here and it has moved up to this. This is height that I'm looking for. I hope this is clear. So here due to hitting it gets the velocity v. So this could be written as m into u could be written equals to m plus m into v, and this v could be written as m into u divided by m plus m. I hope this is clear. Now this is the location number 1, this is the location number 2. Here if I take this as a reference, this is h equals to 0 and it is raised up to here. When I say it can reach maximum to this, I mean here its velocity would be 0. So let's apply total energy at location 1 equals to total energy at location 2. When I say total energy, I mean it's a potential energy of first plus kinetic energy of first. That should be equals to potential energy of second plus kinetic energy of second. So let's do it very carefully. While I say potential energy of first, it's a 0. Why? Because this has been taken as a reference. Kinetic energy of first, it's an half into m plus m, because both are there having velocity v square. The potential energy of second, it's an m plus m into g into h plus kinetic energy. It was 0. So it is something like this, that this could be written as 1 by 2 multiplied by m plus m into v square should be is equals to m plus m into g into h. This m plus m and this m plus m has gone, so this v square could be written as 2 into g into h, and this v square could be written as it's an m square u square divide by m plus m whole square. This is equals to 2 into g into h. So from this you can have this h, which would be is equals to m square u square divide by m plus m whole square into 1 by 2g. So this would be the final answer. This is the final answer, h. I hope this is clear. Yes, this is the final answer. Got this? Have you got this? Are you sure? So can it be done? Can it be done? Are you sure? Are you? Will you do it? Great. So please do remember this kind of things. Now let's have a look to the certain questions. Our first question, what does it say? It says that the coefficient of restitution for a perfectly inelastic, yes, it is zero. Why? It's E is the velocity of separation. E is the velocity of separation. Divide by this is velocity of approach. And when I say velocity of separation divide by velocity of approach, their velocity of separation would be 0. Divide by anything would be a 0. So this is velocity of approach, could be written as u1 minus u2, but it doesn't make any sense. Is it clear? Next, it says that second, coefficient of restitution. Coefficients of restitution depends upon, first it depends on the relative velocities of approach and separation. Yes. The masses of the colliding bodies, does it depend on the masses? Does it depend on the masses? No. The materials of the colliding bodies? No. All of the above? No. So this would be the correct answer, the relative velocities of approach and relative velocities of separation. I hope this is clear. Is it clear? So let's work for the last question of this unit, that means collision part. The coefficient of restitution is, what does it say, is a number which varies from -1 to 1, a number which varies from 0 to 1, a number which varies from 0 to -1, and a positive number. Yes, it's a number which varies from 0 to 1. I hope this is clear. Great. So let's just wind it up this session over here. This is all about the collision. We have done it in separate parts. I have divided elastic collision and inelastic collisions. All the parts above it are for the elastic collision. This is all about the inelastic collision. So now you must know and you must capable enough to do all the questions that are based on the collision. These are very interesting as well as a very very important topic if we understood about examinations point of view. So please at least perform 100 to 120 questions of collision in total. Please do it, then only you can have a confidence on it. Please do it. Thank you. Have a good day. Take care.